Hello everyone, this is lesson 4.7, HL, which stands for hypotenuse leg, and CPCTC. These are the two topics, theorems that we are going to go over today, and we are going to go over lots of proofs. That's the focus for today's lesson. So, and how to use the hypotenuse leg theorem to prove triangles are congruent. That's the last of your theorems, in addition to like the side angle, and angle side theorems. And then CPCTC is a strategy. It's an acronym used after proving that triangles are congruent. It stands for corresponding parts of congruent triangles are congruent. So once you prove the triangles are congruent, you can prove that all of the other parts of the triangle are congruent using that acronym. So first is using hypotenuse leg. It says if the hypotenuse and a leg of one triangle are congruent to the corresponding parts of the other, then the two triangles are congruent. So notice that this is only for right triangles, and it's for if you know the hypotenuse and one of the legs. So it's not both legs, it's not just one of hypotenuse, it's the hypotenuse and one leg. And if you look here in this diagram, it says this basically says the theorem again, and you have triangle JKL, triangle MNP. We have that both of these triangles are right, and you have a leg here, the hypotenuse congruent to this hypotenuse, and one of the legs, the corresponding leg over here, is congruent. So if you notice, this looks like side-side angle. So it's a form of side-side angle that only works because we already know that the angle that's congruent is a right angle. Remember, the problem with side-side angle was that it could make either an acute triangle or an obtuse triangle. But now that we know that the angle that is congruent is a right angle, that third part is a right angle, we know that there's no ambiguity, and we can use this theorem, but we call it HL to signify that it is hypotenuse, meaning that we do have right triangles here. So to use hypotenuse leg theorem, you must show that these three conditions are met. There are two right triangles. There is only one pair of congruent hypotenuses. There is one pair of congruent legs. I don't know why I said only, because you can only have one hypotenuse anyways. So what additional information would you need to prove the triangle is congruent by HL theorem for these triangles? So in order for number one to prove it, well, you already know that there are both right triangles. You already know that one of the legs are congruent, but now you need to know that the hypotenuse is congruent. So you need to know RS and VW. So RS is congruent to VW. That's the third part you need. For this one, you already know that the right angles are congruent, one of the legs, and now you need to know the hypotenuse is congruent, which you can say by the reflexive property. So it's kind of like you already do know that for this one. And then for 3, you have a leg, and you have what looks like it would be a hypotenuse. We just need to know that angle C is the right angle and angle F is the right angle over here. So angle C and angle F are right angles. So the next page, it says, given OF is an altitude of circle O. So this is actually something we're going to learn more about in chapter 5, what an altitude is and why you have this circle that goes around it. It says OF is an altitude, but basically, basically what that means is that it would create, an altitude is perpendicular. So it goes from the vertex of the triangle down perpendicular. So this would form a right angle based off of the definition of altitude. So let's first start off by saying that given OF is an altitude And then we can say that we can then say that OF is perpendicular to EG. That's definition of an altitude. And then if you know that they're perpendicular, you know that they form right angles. So you would then say angle, hang on a second. Angle EFO and angle GFO are right angles. That's the definition of perpendicular lines. And here's kind of an optional step is you could say for this next step is you could say angle EFO and well, actually, hang on a second, not angle, triangle EFO and triangle GFO are right triangles. Because remember, it says the criteria for using hypotenuse leg theorem is that you need to know that you have two right triangles. So if we can state in the proof that you have two right triangles, then we could use hypotenuse leg. So that would be definition of a right triangle. I don't know why that's doing that again. Definition of a right triangle. And step 5. So the other thing that we're going to do is we know that it's a right triangle. Now we need to know that the hypotenuse is congruent to the other hypotenuse. So the way we can say that is if this is a circle and this triangle is inscribed in the circle, which means it fits inside it, then we know that EO and GO are both radii. So then we can say, okay, if they're both the radius of the circle, all the radii in the circle are the same, so we can say that they are congruent. So EO is congruent to OG. EO congruent to OG. You could just say all radii in a circle are congruent. And then for step 6, we can say one of the legs. So you could say the leg that's shared by reflexive property. So that's OF is congruent to itself. So OF is congruent to OF, and that's reflexive property. So finally, you did prove the parts that are necessary for HL. So you can say that the triangles are congruent. You notice we're not at the last step yet. So this is not what we're trying to prove. But we need to prove that the triangles are congruent in order to prove that EF and FG are congruent. Because we can't say that they are yet because you don't know that your altitude is bisector. But now if we know that the two triangles are congruent, then we're going to use CPCTC, which means corresponding parts of congruent triangles are congruent, which we will say on the next page. No, you don't have to worry about writing it down right now, to prove that the third side, EF, is congruent to the corresponding third side of the other triangle, GF. So you only use CPCTC after you prove triangle is congruent to another triangle. You don't use it before, because think about it. It means corresponding parts of congruent triangles. So you have to know that the triangles are congruent first, and then you can prove that all of the other parts that you didn't already prove are congruent are in fact congruent. So if you need to rewatch that description, then just go back a little bit and rewatch it. But that's how you use corresponding parts of congruent triangles. So let's look at a question, a proof that's a little bit more basic and a little bit more of what your homework will be on. And don't worry, your homework is, part of it is an edge elastic, and that part is just like drop down, drag and drop. And then there's another part that I want you to do that's on paper that, according to the WAG and the board, is not going to be due until Thursday, because I don't want to overload you with too much homework, and you will have time Wednesday to do this homework, or tomorrow. So here we have that angle P and R are right angles. So we'll put that first. And then that's given. And you also know that PS is congruent to QR. So PS is congruent to QR. The other thing we could say, and a lot of times this is skipped or implied in the theorems that you don't see it written out, is that since you form right angles, that means you have two right triangles. Okay, we're not explicitly going to say that in this proof. Well, we can, because there's actually another step that we can skip. My apologies. We will say that in this proof. So next we're going to say, because we have right angles, you have right triangles. So triangle, you can say S, well, we'll say it how it is written here. PQS and triangle RSQ are right triangles. That's the definition of a right triangle. And then also the third thing you can say is SQ is congruent to SQ, reflexive property. Technically that'd be SQ is congruent to QS if you name them in corresponding parts the correct order. And then you can say then that their triangles are congruent. This is reflexive property. So triangle PQS is congruent to triangle RSQ by hypotenuse leg theorem. Okay? So we had that one, now we have that one, and now we are moving on to CPCTC. It says once you conclude two triangles are congruent, then you can also conclude that corresponding parts of congruent triangles are congruent. So CPCTC can be used as a justification after you have proven two triangles are congruent. Look at the example proof below. So here we have SU is congruent to SK. So you know this is congruent. And here and here. And then SR is congruent to SH. So I'm actually going to mark that in. That's also given. So we are thinking about the triangles like this. And the other one is like this. So they're kind of overlapping a little bit. And you have angle S is congruent to angle S. So they do share an angle. That's reflexive property. So you know that this side and this angle, and for the red one, it's this longer side. And then for the blue one, it's this longer side that's congruent. And then this shorter side. So side, angle, side. And then after you prove they're congruent, you can prove that angle U and K are congruent. So up here by CPCTC. Sometimes if you prove that two angles are congruent, you can just use third angles theorem to prove that the third angle is congruent. But there's no third side congruence theorem, just so you know. So let's do some examples. So it says GB and GD. GB, GD. Given. Let's do our other given. GU bisects angle DGB. So if it bisects an angle, that means we have angle congruent, angle congruent. So that's what we'll do the next part, definition of bisects. And that's a given for the second reason. So angle, we'll say BGU congruent to angle DGU. Then GU is congruent to GU. Reflexive property. And then you can say the triangles are congruent. So we'll do BGU and DGU. And that is side angle side. And then angle B, and once you prove the triangles are congruent, you can use CPCTC to show that the second angle is congruent. So that actually proved the base angles theorem. So remember how we were saying we learned about isosceles triangles. We did 4.8 before we did 4.7. And now we have proved the base angles theorem. So that's how that ends up working. So now we're going to prove the converse of the isosceles base angles theorem. So we're going to start with saying that the base angles are congruent and GU bisects angle DGB. And, we can draw this angle in, this bisector in any way we want. It's not, we don't necessarily know anything about it down here, but we're just saying, okay, you've got this line here and it's going to bisect angle G. So that's fine. You can do that. There's nothing special about it. We're going to use that idea for the proof. And then because it does bisect, then you have these angles and these two angles. So then that's angle BGU congruent to angle DGU. Definition of bisector. Reflexive property. Now this one though is angle side because the side isn't included. So this is angle side, and we'll name the two triangles. So triangle BGU congruent to triangle DGU. And then GB congruent to GD. So that would be, since we've already, I guess I only need one tick mark there. Since we already proved the triangles are congruent, you can prove corresponding parts of congruent triangles are congruent. What's also unique is that then you can also say that BU is congruent to UD. So that bisector, that angle bisector we drew in for an isosceles triangle, it is also a segment bisector for the opposite side. Okay, so that's something we're going to be looking into in chapter 5, that idea there. Okay, a couple more proofs. Actually, what my notes say is that this is a bonus page. So bonus. And we can do 1 point each. 1 point each. Okay. So if you want to try these ones and turn it in by Wednesday, I would recommend just putting it on a separate sheet of paper so that you can turn the paper in, so you don't have to be without your notes for a day, okay, or a couple days, depending on how long it takes for me to grade it. But I will add it to any one of your quiz grades, and you will get more points from that. So if you want to do this page, it's optional. If you don't, then you can head on off into the 4.7 edge elastic. That's due tomorrow. Oops. And then there's also the 4.7 worksheet on the back table. That is not due tomorrow. It's due the following day. So for this video for this year, that is on Thursday. Okay, if you're watching this in a different year, it might be another day, but for you guys, this is Thursday. All right. Thanks for watching and have a great day.